for this class. Okay, so today we're going to start section 2.4. Will we have a review for midterm? It depends. It depends. So I assign you a homework, a lot of numbers, but I only require you to submit 10 questions. So the rest of it, just prepare for your exams. Okay, prepare for the rest of it, just like a review questions for your midterm and for your final. All right. And of course, we could have one if we need one. Right? So you could ask questions, but in any class, you can ask questions. All right. How long is the midterm? It's like a class time. 1 hour 15 minutes or 1 hour 40 minutes, something like that. Any other questions? Any other questions? If not, let's start. So today we're going to talk about finding arc length of a curve and the surface area. So we want to determine the length of a curve between any 2 points. And we want to find the length of a curve. The first one is we have a function in terms of x. The second one, we have a function in terms of y. You can think this one as the inverse function of f. So g of y is like a f inverse function of f of x. And also we want to find the surface area of a solid revolution. So let's say we have, this curve, the blue color, right? The blue color. We have this curve, and we want to find. Imagine we have a polynomial function, right? It's one piece of string, and we want to find the arc length before any 2 points. So what's the idea? The idea is this. The idea is we're thinking from 2 points, the distance from 2 points. First, we want to approximate. How do we approximate? We want to think that's a hypotenuse of a right triangle. And with right triangle, we can use the Pythagorean theorem to find the length of the hypotenuse, right? Remember a squared c squared equals to a squared plus b squared. So, right? So here, so the length from this point to this point is the square root of difference in x square and the difference in y-axis square. So this delta means a change. Right? Imagine we have this is xi minus 1, this is xi, and so this delta will be xi minus 1. Same thing for the y, right? So the idea comes from here. So then let's use this picture. So let's say in here, how many right triangles we can make? The first one from F naught. So let's say we want to find the distance, the arc length from x naught to x5. So what do? We can cut this into pieces. In this case, we have 1, 2, 3, 4, 5 pieces. And each one from x naught to x1, the arc length we can approximate with this, right? And then we can imagine that's hypotenuse of a right triangle. So we just find, so we just square root of the distance in x, so delta x squared plus delta y squared. Right, for this one, we just do this right triangle. We do the same thing, so on and so forth. So in this case, we would have 1, 2, 3, 4, 5, right? We separate it into 5 pieces. So same idea as before. In this case, n equals to 5. But we could let n run into infinity. That means from x0 to x5, we cut the arc length into infinite many pieces, right? And each one will approximate as the hypotenuse of a right triangle. Then we have this formula. So we have this, so square root of delta x squared plus delta y squared from Pythagorean theorem. Right, we can cut into how many pieces? N pieces. So how does this change from delta x squared, delta y squared to this square root of 1 plus this one? So I'm going to explain this more in whiteboard. So for now, so we're cutting that one from x0 to xn into n pieces, right? So I have this square root of this 1 plus, I will explain this 1 plus a derivative of f squared, then delta x. So then we let n run into infinity, right? So take a limit, that n approaches infinity. So we get this arc length formula. So from A to B, let's say x equals to A, x equals to B, we want to find arc length. So we have this square root of 1 plus this. Okay, let me go to whiteboard to explain how did this change? How does this change? So how did we go from square root of delta x squared plus delta y squared to delta x? Okay, when we talk about infinity, so when we let n run into infinity, right? So we use the infinity idea. So that becomes dx squared plus dy squared, right? The upper one is n pieces, cut into n pieces. Oh, no, this one, right? So square root, so the hypotenuse, the arc length equals the square root of this, right? Each small piece. Then when we talk about let n run into infinity, so we change it to be dx squared plus dy squared. Now I can factor out dx squared, right? I can pull dx outside. So I factor out dx squared. So square root of dx squared is just dx, right? So this one becomes 1, and this one becomes dy over dx squared, right? So I factored out dx squared. So I get this. I get 1 plus dy over dx squared. Then this dx is outside now. And what's dy dx? That's the derivative. No, this is not a proof. This is just to explain, why the textbook goes from this one directly to this one. Just to explain to you this. Or you could think this as a proof, all right? There's no problem to think this as a proof. Square this one, right? So dy dx is just derivative of the function with dx outside the square root sign. Okay, does this make sense to everyone? So this is just explanation of the text. All right, good. Of the textbook, because the textbook jumped from one notation to another notation. So that's how we get this. How we get it? Okay. We want to find out the arc length from A to B. So what do? We set up an integral from A to B. You know, we have the square root of 1 plus f prime squared. Okay, that's it. So this is a formula finding arc length. Let's see an example. Oh, okay, arc length. So f is a function, smooth function. What does it mean, smooth function? Smooth function means in the interval AB, at every point we can take a derivative. Okay, derivative exists. So that means smooth function. Over the interval, then the arc length of the portion of the graph from the point A comma f of A to B comma f of B is this. It's the integration from A to B square root of 1 plus derivative of the function square. Let's see an example. So let's see f of x equals to 2x raised by 3 halves. So that's 2x square root of x, right? Okay, we want to find the arc length of the graph over the interval from 0 to 1. All right, so just use the formula. Take a derivative of the function. It's a 3x, it's a 3 square root of x. Then we square this function, we get 9x. So we'll put it into the formula. Integration from 0 to 1, square root of 1 plus a derivative of f squared, which is 9x dx. Then we use the substitution method. Substitution, then power rule. So let u be 1 plus 9x, then du equals 9 dx, or dx equals du over 9. So when x equals 0, u equals to 1 plus 9 times 0, which is 1. When x equals 0, right, u equals 1. When x equals 1, we have 9 times 1 plus 1, which will get u equals 10. So we can change our integration in terms of u from x. We get a 1/9 because dx equals the 1/9 du, right? We get a 1/9 integration from 1 to 10 square root of u du, right? Now square root of u. So we'll anti-differentiate with the power rule. Then we just do calculation. Okay, the book estimate into a decimals. So we normally don't like to do that. Just keep square root form, keep square root 10, all right? Keep square root 10, because that's the exact answer. Keep like this. So we may simplify this. So we would get 20 over 27 square root of 10 minus 2 over 27. What does keep like this? Keep like this one. But if you really want to say the length, you can approximate with 2.268. Okay, anyone has any questions? All right. Well, So let's see this one. So f of x equals to 4 over 3 x square root of x. Then we want to find the length, arc length between 0 and 1. Okay, let's all try this one. Then type your answer in the chat. So I'm going to do myself also. Okay. Oh, it's about this. Okay, you could use that to approximate, or you may write, so preferably, so 1 over 6, I got 1 over 6 square root of 5. Well, then you got pi over 6? Where did pi come from? This is what I got. 1 over 6 square root of 5 minus 1. We all got it just 1. Okay, let's go to the whiteboard. Let's go to the whiteboard for this. Yeah, I'm going to do that. Let's go to the whiteboard. Okay. So the function is f of x equals to 4 over 3 x raised by 3/2. So first step, we take derivative of this. So that means f prime equals to, well, 4 over 3 times 3 over 2, that equals to 2, right? I'm not going to write. So 4 over 3 times 3 over 2, that's 2. Then minus 1 from the exponent of x, 3/2, you get x raised by half, right? Or just a square. Oh, did I do this right? Yes, right? So now the formula, the arc length, we want to find from the interval 0 to 1. We have a square root of 1 plus the derivative square. Well, 2 square is 4. X raised by half square, just x, dx. Right? Then you could think about u substitution, right? You let u be 1 plus 4x, then du will be 4 dx. Or dx is just 1 over 4 du, right? I don't need to write that down, right? So I got a quarter. I'm not going to write the limits. Well, I could. Let's see. It just becomes u raised by half. So 1 plus 4x is u now. Right? So u equals 1 plus 4x. So this is u half. Then du equals 4 dx. Or dx equals 1/4 of du. What about the limits? X equals 0. U equals 1 plus 4 times 0, just 1. X equals 1. 1 plus 4 times 1. 4 times 1, which is just 4, plus 1, which is 5. Right. Now, which is anti-differentiate, you have, so we got 1/4 times 2/3 u raised by 3. Oh, u raised by 3/2. Actually, my answer missing something. My answer missing 5. So 5, because this is 3/2. We want to evaluate from 1 to 5. Simplify this, got a 1/6, right? 1/6. Then when u is 5, that's 5 square root of 5. Right, I'm missing this 5. 5 square root of 5. When u is 1, that's just 1. That's a minus 1. Right? That's it. So leave this answer. So this answer is exact. Leave answer like that. Yes. Shihaya got it right. Damon got it right. So probably it's 1.697. I see so many of you have this answer. Okay, anyone has any questions? Can you explain how you got the upper and lower bounds again? Okay. So I set u to be 1 plus 4x. Right? So basically you can think u is a function of x, right? So what's u of 0? Because the lower limit is x equals 0, right? So here is x equals 0. Because the variable is x now in here. We use red color. Right? Then this x equals 1. So u, think about u is a function of x. U equals to 1 plus 4x. What's u of 0? U of 0 is 1. What's u of 1? Plug in x equals 1. That's 5. Right? Does that make sense? Okay. All right. Any other questions? Okay, let's go back to the textbook. Okay, that's that. Let's see this one. Use a computer or calculator to determine the arc length of function. Why? Let's not do that. Let's see. X squared, when we take derivative, we just get 2x, right? So 2x. Oh, we see. We have x squared now, right? We may use trig functions to do that because we have square root of 1 plus 4x squared. Let's see the book. What did the book does? So derivative is 2x. So when we square, we get a 4x squared. So now the integrand is square root of 1 plus 4x squared. The interval is 1 to 3. If we use a calculator, we get that. Let's see. But we can use trig functions, right? Anyway, so this problem, they just want you to use a computer or calculator to approximate. Okay, sometimes we want to find arc length in terms of y. In terms of y. In that case, we just set up the integral as square root of 1 plus the derivative in terms of y squared. Okay, that's the only difference. Let's see this one. So we have a function g of y equals 3y cubed. And we want to find arc length in between 1 to 2. So g prime is 9y squared. So when we square g prime, we get 81y raised by 4. We plug in, we get integration from 1 to 2. The integrand is square root of 1 plus 81y to the 4th power. We could use a computer or calculator to approximate, so get up this much. Okay, area of a surface of revolution. So from certain point to certain point, if we revolve this region over x-axis, we get a 3D objects. I want to find a picture of showing the surface. Okay, so the surface area is the total area of the outer layer of an object, right? So for this one, so it's just outer, it's just like a skin of this 3D object. So the idea is, oops. The idea is similar. We cut into n pieces, then we let n run into infinity. Okay, I want to find an easy example first. Okay, let's see. Yeah, okay, let's go with this. So we cut into n pieces first. So we have this 2 pi r. As we know, what's that? That's the circumference of the rotating, right? So when we rotate, again, we get a perfect circle. We got a perfect circle. We want to get an area. We want to get the circumference of the circle, right? Which is 2 pi r. And when we rotate with x-axis, the radius r, just the function value at the point x. So we have this 2 pi r. Then the rest of it, the idea, right, the delta x is another dimension. And the square root of 1 plus this we know is the arc length. It's the arc length. So that's the formula for surface area of n pieces. Then we let n run into infinity. Okay, so then we let n run into infinity, so we get this formula. So the surface area of a 3D object from A to B is a 2 pi f of x. Well, of course, this is revolving with x-axis, right? Rotating with x-axis. So we have 2 pi f of x, right? So this is one dimension. This is the circumference of the circle. And then what's the width? So circumference of circle, we think as the width. What's the length? The length is square root of the arc length, right? The arc length, square root of 1 plus f prime squared. So we're cutting along x-axis into infinite many pieces. So this is the formula. So anyone has any questions? All right, so it's easy to understand, right? Think about the piece in front of you. We're cutting into n pieces, and each one we approximate with a rectangle. Rectangle length is the circumference of the circle. Width is just the difference, just the arc length, right? Then we cut into, from A to B, we cut into infinite many pieces. All right, so this is rotating with x-axis. Well, let's see an example. Well, similarly with the y-axis, right? If we get a function in terms of y, you know, just change the function to be in terms of y, then anything else is the same. Let's see an example. Okay. Here we have a square root of x as a function. We want to find, from the interval 1 to 4, we want to find the surface area of this, rotating the graph of f of s with x-axis. So we want to find, oops, surface area. Square root of x. So when we rotate, we get this, right? So we want to find the surface area of this object from 1 to 4. So derivative of f is 1 over 2 square root of x. And square that, we'll get 1 over 4x. Use a formula from A to B, from 1 to 4, right? From 1 to 4. From 1 to 4, so 2 pi, function is the square root of x. Then we have square root of 1 plus derivative of f squared, which is 1 over 4x. Then we can multiply square root of x with this square root of 1 plus 1 over 4x. So we get x, we get the 2 pi square root of x plus quarter. And we could use u substitution, right? U equals x plus quarter, du equals dx. Then we can change the limits. When x equals 1, u equals to 1 plus 1 over 4, which is 5 over 4. When x equals 4, u equals to 4 plus 1 over 4, which is 17 over 4. Then we change the variable from x to u. So we get lower limit 5 over 4, upper limit 17 over 4, 2 pi u raised by half. Then anti-differentiate by power rule. So in the end, we get this. This one we get pi. Okay. So anytime when we deal with a circle, we get a pi. Right? You can leave as pi over 6, 17 square root of 17 minus 5 over square root of 5. Okay, anyone has any questions? Okay, keep going. Well, everyone try this one, 2.21. So the function is the square root of 1 minus x. Now you have dx equals negative du. Okay, from the interval from 0 to half. I'm going to try myself also. Okay, this one answer with pi, right? Pi times 5 square root 5. Oh, that's before. Oh, it's now? Okay, we want to find the surface area. Pi square root 5, pi over 6, pi over 6. Okay, I got a pi over 2. Let's go to the whiteboard. Let's go to the whiteboard. So the function is square root of 1 minus x. So let's find the derivative. Derivative equals the half. Then, so this is 1 minus x raised by half. So we got a half minus 1, which is a negative half. So we get this, 1 over 2 times the square root of 1 minus x. Pi over 6, okay. I see a lot of you have that. So I get this, right? So the formula is from 0 to half 2 pi r, I'll bring 2 pi outside, 2 pi f of x, which is the square root of 1 minus x, right? So 2 pi is constant, I bring outside the integration, f of x times square root of 1 plus, I better do this square. So let's square this. So let's square this. So the numerator is just 1. 1 squared is still 1. The denominator, 2 becomes 4. Square root of this now becomes just 1 minus x. Right? So 1 plus 1 over, oh, I think I know why now. 4 times 1 minus x. Then dx. Okay, I think most of you got the right answer. Now, both under square root, we see this 1 over x simplify with this 1 minus x, right? So what's left? So left with 1 plus quarter. Square root of 1 plus quarter. That's just the square root of 5 over 4. Right? Square root of 5 over 4, so it's just square root of 5 over 2. Because square root of 4 is 2, right? Multiply this 2 pi, because they're all numbers now, right? So these cancel each other, we get a square root of 5 pi. And then what about the rest? We have 0 to a half dx, right? So this part is constant. It's constant. So just half, right? Just half. So we have in the end, we get a square root of 5 over 2 pi. Let's see. Pi square root 3. Where did you get square root of 3? Did I make any mistake? Let's go back to check. Let's go back to check my answers. Okay, f is defined this way. Derivative of f is 1 over 2 times square root of that. And when we square that, we get 1 over 4 times 1 minus x. The formula is 2 pi f of x times square root of 1 plus derivative square, which is 1 over 4 times 1 minus x. Both under square root sign, we can cancel out 1 minus x divided by 1 minus x. So left with square root of 1 plus 1 over 4. That's just a constant number, right? Square root of 5 over 2. We multiply with 2 pi, get the square root of 5 pi. And the integrand just becomes 1, just dx. So that's constant. So we just do half. So half minus 0, which is half. So half times square root of 5 pi. That's right. I think this should be the right answer. Square root of 5 divided by 2 pi. Okay, anyone has any questions? You may check to see where you made a mistake, right? Okay. Let's go back to the text. Why is it over 2 again? Because that's from this. We have anti-differentiate from 0 to half dx. Because the integrand is a number, it's a constant number now. If it's a constant, I can pull out outside. So what's the integrand here? It's just 1. Or square root of 5. So this part gives us a half. Don't you have to do U substitution? Not really. Because you see the beautiful thing is this. You see when I multiply, so this and this all and this. Oh, I made a mistake. I made a mistake. I have 1 here. I cannot cancel out 1 plus x. Oh, I made a mistake. Thank you. Thank you. Thank you. No wonder I was thinking why my answer is different from yours. So this is, okay, this is not this. So I'm missing integrand here. Let me insert my integrand. My integrand, so this 1, I can change it to be 4 times 1 minus x plus 1. So I need to do 1 plus 4 times 1 minus x. I forgot this 1. That's my mistake. Okay. So then I can cancel this 2. I still can cancel this 2. But my integrand would be 1 plus 4, which is 5. So square root of 5 plus minus. So 4 times 1, that's 4. 4 plus 1, that's 5. 5 minus 4x. Yes, I have to use U substitution. I'm sorry. I have taught 3 classes already. So my brain doesn't work properly. So we need to use U substitution. So U equals to 5 minus 4x. Sorry. So du equals to -4. My goodness. Right? So then we do the substitution. So this is totally wrong. So this answer is wrong. Right? So let's redo this. So the limit need to be if x is 0, u is 5. If x is equals to half times 4 is 2. 5 minus 2, that's 3. Right? Then square root of this. Square root of 5 minus 4x dx. Oh, no, I want to change this to u. That's a u raised by half. Then dx becomes negative du over 4. Right, so again, negative 1/4 up front. So I have this negative sign here, but 5 is bigger than 3. I want to switch these two limits. So I'm going to switch 5 as upper limit, switch 3 as lower limit. That offsets by a negative sign. So negative, negative become positive. So I get a quarter, integration from 3 to 5, u raised by half. Okay, so anti-differentiate, that's a quarter, u raised by 3/2 divided by 3/2 is the same as multiplied by 2 over 3. Then evaluate u from 3 to 5. Okay, so most of you got the right answer. So now this simplifies to be 1 over 6. I can write equal sign here. Then 5. Oh, also I have this 2 pi. I need to multiply this 2 pi. So multiply 2 pi, I get a pi over 3. Right? 5 radical 5 minus 3 radical 3. Okay, any questions or comments? Okay, I see some of you have pi over 6, pi over 6. Maybe I made mistakes again. Pi square root 3, pi over 6. Okay, so that's pi over 3 multiplied by parentheses 5 radical 5 minus 3 radical 3. All right, anyone has any questions? Okay, let's go back to the test. Okay, calculating the surface area of this surface revolution with y-axis. All right. So the function is given still as f of x. So f of x equals to cubic root of 3x. And we want to find the surface area rotating with the y-axis from 0 to 2. So what do we have to do? We have to write this function f of x as the inverse function. So we need to find inverse function of f of x, which is just 3x, right? We cube, so we raise both sides by 3. So we get the inverse function g of y, or inverse function of f, we call g of y, equals 1/3 of y cubed. So if we draw the graph, 1/3 of y cubed, right, that's 1/3 of y cubed. I think there's some other conditions. From 0 to 2, right? So we want to find the surface area of this region, rotate with y-axis So basically, it's this cone, the surface area of this cone. So we just follow the formula, right? We find the g prime of y, which is a y square. We square that to get y raised by 4. So surface area is from 0 to 2 pi g of y. G of y is 1/3 of y cubed. Square root of y, 1 plus y to the 4th power. Then we can use u substitution. So let u be y raised by 4 plus 1. Then du equals 4y cubed dy. Or y cubed dy equals 1/4 of du. Then we change the limits. So when the limit is 0, u equals to 0 raised by 4 plus 1, which is 1. When the upper limit is 2, u equals to 2 raised by 4, which is 16, plus 1, which is 17. Now we change the variables and the limits. So we get 2 pi over, we can always pull out the scalars outside the integration. So 2 pi over 3, the limit from 1 to 17. Quarter, we can even pull outside. We would get 1 over 6 pi. U raised by half, multiplied by 2/3. U raised by 3/2. Do the calculations, we'll get this. All right, so the technique is the U substitution, right? The U substitution. Okay, anyone has any questions with this? And also the difference of this one from before is we're given function of x, a given function of x in terms of x, but we want to find surface area in terms of y. So we're cutting along y-axis into infinite many pieces. So that's why we have to find the inverse function of f, which we call g of y. And the rest is the same way. Anyone has any questions? Okay, keep going. Okay, let's all try this one, 2.22. That's fast. Oh, this was easier, huh? Yes, I have 12 pi also. Yes, I got 12 pi also. Anyone has any questions over this? All right, so I'm going to assign you homework from here too. And now let's talk about physical, let's see. Okay, we're going to skip this one. Moments and center of mass. So this is the application of, let's see, for the center of mass or object. Look at the center of mass, I think like use symmetry. Okay, we're going to skip this also. Okay, 2.7. So 2.4 and 2.7. Let me remember that. So skipping 2.5, 2.6. So 2.4 is dealing with natural logs. Okay. So natural log as an integral from the anti-differentiate of the power rule is this, right? But we require in the power rule, the n cannot be -1. N cannot be -1. So n can be any other integers, but not -1. So when n equals to -1, that's 1 over x, which is special. So what do? We, from the fundamental theorem of calculus part 1, right? If integral from 1 to x, 1 over t dt is just the antiderivative of 1 over x. So we make this definition. So natural log of x equals to integration from 1 to x, 1 over t dt. Right, so we could use, well, the domain of natural log is the variable has to be greater than 0, right? So this is the definition of natural log in terms of integration by using fundamental theorem of calculus part 1. So the picture is this, right? From 1 to x, right? From 1 to x. So the integration of from 1 to x, 1 over t. So this area, the quantity of this area is just ln x. Okay, it's just ln x. Well, the from 1 to a negative x value, I mean smaller x value. So this is from 1 to the value bigger than 1, from 1 to the right. Then we have ln x. But when x is less than 1, we get negative ln x, right? Because negative ln x, because this is a fraction now. Think about half, right? Think about ln half. What's ln half? It's a negative ln 2. Okay, derivative of natural logs is just a derivative of ln x equals to 1 over x. We remember this, right? This is the ln x graph. The domain is x has to be greater than 0. So let's try this. Let's try to calculate the derivative is of natural logs. So A, we want to find a derivative of ln 5x cubed minus 2. That just equals to 1 over 5x cubed minus 2, then multiplied by chain rule, multiplied by the derivative of 5x cubed minus 2, which is 15x squared. Right? So B is this ln 3x, then parentheses square, so we square the ln. So when we take a derivative, well, first by power rule, right? By power rule, I have 2 ln 3x raised by 1, because 2 minus 1 is 1. Then by chain rule, multiply by 3, and by chain rule, ln of 3x is 1 over 3x, right? So simplify, we get 2 times ln 3x over x. This we know from before. So let's just skip this. I believe everyone can do this. So now we have a theorem. So integral of 1 over x, or 1 over u. It is ln absolute value of u. Okay, because ln, the domain of ln has to be positive number. So we use absolute sign to force that. Plus, right? For indefinite integral, we have the plus constant c. So let's see this one. We can use u substitution. So we let u be x squared plus 4. Then du equals to x. So x dx equals half of du. So we just get a half of 1 over u. Now 1 over u, we know anti-differentiate, we just get ln absolute value of u. So half of ln absolute value of u plus a constant. Right? U is just x squared plus 4. And x squared plus 4 will always be positive number. So we don't need to use absolute value sign to force it. So we just ignore that. In the end, we get a half of ln x squared plus 4 plus a constant number. Anyone has questions? All right, keep going. All right, why don't you all try this? 2.36. Ali, ln x cubed plus 6. Okay, James has wondered of ln absolute value of x cubed plus 6 plus c. Yes, I agree with Paul. Oh, Paul is missing absolute value sign. X cubed plus 6 has to be forced to be positive, because x cubed can be negative. So we use absolute value sign to enforce positivity. Okay, right. Ali, you're missing 1/3 because dx, x squared dx equals to 1/3 of du. Okay, looks good. Just Alexis, just remember x cubed plus 6. So domain of ln has to be positive. So use absolute value sign to enforce that. Okay, looks good. All right, anyone has any questions? Great. Okay. People, you have to use absolute value sign to enforce the value of ln to be positive. So put the absolute value sign around x cubed plus 6. All right, pretty good. Let's see this one. So properties of the natural logs. Of course, we know ln 1 equals 0, ln of a product equals ln plus ln. So product of ln can be split into plus of 2 ln's. A division is a subtraction, and the exponent can be pulled up front. So we know all this. You can go through these proofs, all right, by integration. Because if we made a definition like this, it has to work for all the properties, right? So I'm not going to go through that. So you can go through this. Of course, ln e equals 1 because ln is log base e. E is called an Euler number, right? Just like a pi is a constant number. Exponential function and the log function just inverse with each other. And it has a symmetry. Any inverse functions is symmetric with a line y equals to x. So ln e to the x equals x. Yeah. Because all the properties. Let's just go through this quickly. So if we take a derivative of a product of exponential functions, right, we can use the property. So derivative, well, that's just 3t plus t squared added exponents, right? When we take derivative, the e term always have the e term multiplied by the chain rule, the chain part. Okay. Let's see, how do we use in exponential in integrations? So let's anti-differentiate 2x e to the negative x squared. We use u substitution. So let u be negative x squared, then du equals negative 2x dx, right? So substitute x terms into u terms. So get this. Then we anti-differentiate. So once we have e to the u, anti-differentiate is just e to the u itself. Right? Then we substitute back the value for u. So this is called indefinite integral. So get negative e raised by negative x squared plus c. Anyone has any questions? Okay. A to the x equals to e to, let's see what it is. Okay, y equals to a to the x exponential equation, right? Can be written as e to the x ln a, right? When we take ln on both sides, we get ln y equals to x ln a. Then we put x to be the exponent of a, so we get ln a raised by x. So that's still y equals to a to the x. So basically, you can write this way. So when we differentiate a raised by x, so a is not e anymore. A can be any number, any base, but it's positive. Okay, we want a to be a positive number. So a raised by x. So that's just the same as differentiate e raised by x ln a. So we have e term, then we have the differentiate, we have the chain part by chain rule, we have ln a. So we get a raised by x times ln a, right? If it's e, if a equals e, which is just e to the x, ln e, which is 1. So e is just a typical a. So differentiate any exponential term like this. We get the term, exponential term itself multiplied by natural log of the base. And we can take an integral. So integration of a to the x, that would be 1 over ln a of the exponential term plus a constant. All right, let's see some examples. Okay, derivative of log base, any base a of x equals to 1 over x times ln a. So before we have 1 over x, right? ln, if log a is log base e, right, we just have 1 over x because ln e is 1. But for any other base, we have 1 over x multiplied by 1 over ln a. All right, let's just try those two. So differentiate 4 raised by t times 2 raised by t squared. We can combine those two, right? 4 raised by t is 2 raised by 2t. So we get 2 raised by 2t plus t squared. And when we take a derivative of that, so the exponential term stays, so 2 raised by 2t plus t squared. Now multiply by ln a, or a in this case is just 2, ln 2. Then by chain rule, we have to differentiate the exponent. The derivative of the exponent is just 2 plus 2t. Okay. The second one, we want to take a derivative of log base 8, 7x squared plus 4. So that's 1 over whatever the value inside, which is 7x squared plus 1 over 7x squared plus 4. Now, also multiply by 1 over ln 8. 1 over ln 8. Then multiply by the derivative of 7x squared plus 4, which is 14x. So get this. Anyone has any questions? All right, keep going. Okay, let's try to integrate this one. So integrate, so this is indefinite integral. We always anti-differentiate, then plus c, right, plus constant. So the integral is 3 divided by 2 raised by 3x. So let u be 3, let u be negative 3x, because we have 2 raised by negative 3x, right? So let u be negative 3x, and du then equals negative 3 dx. And we see 3, so we have 3 dx here. So that's 3 dx equals negative du. So we substitute, we get negative, so 1 over 2 raised by 3x now becomes 2 raised by negative 3x. It becomes 2 raised by u now, right? So we get negative 2 raised by u du. And anti-differentiate 2 raised by u, we get 1 over ln 2, because the base is 2, right? Negative sign, negative 1 over ln 2, 2 raised by u plus a constant term. And the u is negative 3x, so we just get negative 1 over ln 2, 2 raised by negative 3x plus c. Well, we should write 2 raised by negative 3x in the denominator, right? So negative 1 over ln 2 times 1 over 2 raised by 3x. Any questions? Okay, you try this one. Oh, anyone has any questions? Let's see. Could you repeat the last part? Okay, sure. Usually we don't like, so if we have 2 raised by negative 3x, we don't consider that one as simplified. So we would rather write the answer for this to be 1 negative 1 over ln2 times 1 over 2 raised by 3x. Okay, so 2 raised by negative 3x. We would rather write 1 over 2 raised by 3x plus c. All right. Now you try this one. Let u be x cubed, then du equals to 3x squared dx. So x squared dx equals 1/3 of du. Okay, go along, get 1/3 ln x squared, ln x squared x2. You
ln times 2, 3 ln times 2.
Oh, okay. Just write ln2. ln2, okay. ln cannot times 2. Okay, let me write for you. So 1/3 of ln of 2. So ln takes the value of 2. Then the e term, not the e term, the 2 raised by x cubed. Oh, this is difficult to write. Let's see if this makes sense. Plus c, right? Plus c. Let's see. So 1/3, right, divided by 1/3 ln2. Right, I should use parentheses. So 1 over 3 ln2 multiply 2 raised by x cubed plus c. Okay, looks great. Looks great. Yeah, 2 raised by u, so u is x cubed. 2 raised by u. Okay, let's go back. Let's go back to the formula. Right here. So when we take a derivative of this, this is 1 over x ln a, but when we anti-differentiate, right here. So when we anti-differentiate a to the x, well, in our case, sometimes we need to substitute into u, a to the u. That just equals 1 over ln of the base. In our case, that's 2. Base is 2, right? Then the exponential term, a to the x is exponential term. In our case, it's 2 raised by u, 2 raised by u plus c. So when we take a derivative, we have a multiplication. We have the exponential term multiplied by ln. So when we anti-differentiate, we have 1 over ln a, 1 divided by ln a. All right. Okay, great. Anybody else has any questions? All right, I'm going to make some homework for 2.7. So we have 2.4, 2.7. Now we can tell exponential growth and decay. We're going to skip that. Hyperbolic functions. We're going to skip that. Okay, let's see what's technical for integration. But okay, let's go talk a little bit about integration by parts. This is very important. Integration by parts. All right, let's use this one. So let's think about a product of, so h of x is a product of two functions, right? So h of x equals f of x times g of x. So when we take a derivative of product of two functions, we take a derivative of the first one multiplied by the second one, then plus the derivative of the second one multiplied by the first one, product rule, right? So now, when we anti-differentiate that, so when we integrate that, so we get this. Integration of the derivative of h equals the anti-differentiate of this. And we can rewrite this one. We can rewrite this one as this. So this gives 2. So we can rewrite this as this, right? And this is called integration by parts. So it comes from the product rule. Right? You see, this is a product of two functions. Oh, that should be so this should be h of x, right? So this gives us h of x, which is the product of two functions, equals to integration of this one and plus integration of this one. So that means we can write this into 2, right? We can write it as, we can move one of the integration to the other side. We will get f of f times g minus the other part of integration. So this is called integration by parts. So sometimes we see, let's go to one example. Let's go to one example first. Let's see this one, right? So the integral is x times sine x. You know, by the skills we know, the integration skills we know, we have no idea how to integrate this, right? Because we have product of two functions. And the sine x, derivative of sine x is cosine x. Well, integration of sine x is negative cosine x, right? But we don't have cosine x in the integrand, and we have x. So x dx is not a derivative of sine x. So it's like we stacked. So what do? We can use integration by parts. So what do? We think as x and the sine x is some derivative of other functions. Right? Then we write this way. That equals to the original product of functions minus anti-differentiate the other part. Okay, so in this case, so a lot of times you see books writing this way. Differentiate u dv. So we have two functions. So the integrand is a product of two functions. So we're going to treat one of the functions to be derivative of other function. Right? So u dv equals to uv minus v du. Well, now this is very abstract. Let's use the example. Let's use this example. So in this example, we want the u to be x, because when we take a du, we just get a du equals to dx. Right? Then dv equals to sine x dx. Then we can write v. V is equals to negative cosine x. So u equals to x, then du equals to dx, and dv equals sine x dx, then v equals to negative cosine x, right? So we get, v equals to negative cosine x. Then we rewrite this, we rewrite the integration of x dx to be, so integration of x sine x dx to be the original function x times, so u times v, u is x, v is negative cosine x, minus anti-differentiation, du and v du. V is negative cosine x, du is just dx. We simplify, anti-differentiate cosine x, it's just sine x. So in the end, we get negative x cosine x plus sine x plus c. All right. So in this case, we let u be x, then du equals to dx. Then sine x dx, we let it be dv. Then anti-differentiate dv, so we get v equals 9 negative cosine x. Then we just substitute everything into differentiation, anti-differentiation, integration by parts. Okay, anyone has any questions? So try to remember this. Try to remember this, okay? Whenever the integrand we say is a product of two functions, and there's no way we can integrate, by other methods, so then we can use integration by parts, right? So we recognize one of the function as u and the other function as a dv. Then we figure out du, we figure out v. So that equals to uv subtract integration v du. Any questions? Okay, let's see more examples. Let's try this one. Okay, so this one, so let's all try 3.1. So they give us a hint. They say, let u be x, let dv be e to the x 2x. Will we always be given the hints, or will we have to eventually we have to determine ourselves which part we want to be v, or which part we want to be u, which part we want to be dv. Yeah, you will, right. All right, what do we get? So from u equals to the x, we figure out du equals to dx. Right? So from dv, so we just integrate, which is anti-differentiate dv, right? Anti-differentiate dv, or equals anti-differentiate e to the 2x dx. That's just a, so that means v. So anti-differentiate dv, we get a v. V equals to half e to the 2x, right? So now we get u times v. So u times v is x times e to the 2x. Yeah. Or permissible, you're missing x, right? X times e raised by 2x divided by 2 minus e to the 2x divided by 4 plus c. A little bit different from mine. Maybe I made a mistake. Let's see. So I have u equals to x, and then du equals to dx. dv equals to e to the x dx. Then anti-differentiate dv, I get a v. v equals to half of e to the 2x. So I get a u times v. So u times v is x times e to the x divided by 2, or half of that. Then minus integration of v du. So v is half of e to the 2x. Oh, that's quarter, right? That becomes quarter of e to the 2x. Right, so half. So uv is half of x times e to the x minus quarter e to the 2x plus c. So let's see. So half, so Paul, Shahara, Damon, you have 2. That should be half. Yeah, my answer is the same as Shahara's. Is the same as Paul's. So Zachariah plus C, right? Okay. Damon, do you see why it's not 2 but a half? Raw, you have plus quarter times e to the 2x, or minus? Minus, right? Because it's uv minus integration of v du. So it should be minus. Okay. Okay, pretty good. All right. All right, okay, great. Let's see, let's keep going. Anyone has any questions? Plus C, right? Okay. Anyone has any questions? Yes, Kelly. You can submit late homework, but will be, you won't get full credits for it. But remember to write homework numbers as subject title. Okay, anyone has any questions with this? All right, let's keep moving. You're welcome. Okay, integration by parts. So now we have ln x multiplied by x raised by -3. So which part we want to be u, which part we want to be v? So we want u to be ln x, because when we take a derivative of u, we get a 1 over x, right? So u be ln x, then du will be 1 over x dx. And then 1 over or x raised by -3 dx will be our dv. So anti-differentiate dv, we would get -3 anti-differentiate dv. So v equals to anti-differentiate dv, which is anti-differentiate x raised by -3 dx by power rule. We get x raised by -3 plus 1, which is -2. Then we divide by -2, which is -½ So we get -½ So v equals -½ x raised by -2. Right. So now we have these four members. Of u equals ln x, du equals 1 over x dx, and dv equals to x raised by -3 dx, and v equals to -½ x raised by -2. Now we just use the integration by parts formula. Right, so equals to u times v, which is ln x times -½ x raised by -2, minus integration of v du, right? V is this guy, and du is this guy, so we just multiply. We simplify, so get this, -½ x raised by -2 ln x, and this in the end we can write x raised by -2 in the denominator is -1 over 2x squared in the denominator ln x. Then anti-differentiate half x raised by -3, we get quarter x raised by -2, so we can write as 1 over 4x squared plus c. Okay, so as you can see, right, the work, the job is on to identify who is going to be u, who is going to be dv. Sometimes, you know, if one way doesn't work, we just go another way, right? If we identify u and dv, it won't work, then we just switch. Is there always only one right function to use sub? Not really. Maybe there are different ways of doing that. Maybe both functions can be identified, you know, to be u and dv. It doesn't matter. Sometimes we just have to try by, you know, trial and error. Okay, let's try this one. So x ln x dx anti-differentiate. X ln x. Oh, I'm sorry, it's time. All right, so you may try this on your own, and also this one. You know, sometimes we need to apply integration by parts couple of times. Okay, couple of times. So let's see this one. Let me just go over this one. So we have x squared e to the 3x. If we apply integration by parts once, you know, we still won't be able to do it. We still have x e to the 3x in the integral. We still have product of two functions. So we just, you know, apply again. Apply integration by parts, you know, one more time. All right. Okay, so you try those examples. I'm going to assign you homework like this one also. Sine of ln x. So ln x is the angle. Okay. We have to apply twice, or sometimes even more than twice. Okay, so today I covered 3 sections. So finding arc length, finding surface area is pretty easy. So the main work is integration by parts. All right, I'll assign you some homework if we still have problem because it's weekend. So I'm hoping you have more time to do your homework. Try not to submit your homework late because it won't be worth it. Because homework is for you to practice, right? After class, you practice. All right, anyway, anyone has any questions? Is it late if it after 8 a.m. before class? Oh, I didn't change the time, right? Right, same day, won't be late. You know, as long as you submit before that date, it's okay. Okay, any other questions? Thank you. Have a good weekend. Good night.